We are going to go over lessons on sample space, otherwise known as possible combinations. You guys did this in 4th and 5th grade. The first one looks at this little bag right here with the different colors. They have different colored tiles. We have a yellow, a blue, a red, and a green. We also have a spinner over here that has a square, a triangle, and a circle. So they want to know if you pull one tile from the bag and spin the spinner once, what are all the possible outcomes that could take place? Well, first we want to list what we have. We have yellow, we have blue, we have red, and we have green. And that's in our bag of tiles. Then in our circle we have, or spinner, we have a triangle, we have a square, and we have a circle. So looking at my list, I'm trying to figure out how many possible combinations can I make without making duplications. So I could do a yellow tile and a triangle. Now to organize so that I don't miss anything, I'm going to try to get all the possible combinations with yellow out first. So then I could also do yellow and the square. I could also do yellow and a circle. Well, so far I have 1, 2, and 3 possible combinations. It looks like I'm done with yellow. I'm going to move on to blue. I could do blue and then land on the triangle. I could pick out a blue and land on the square. I could pick out a blue and land on the circle. Well, then I have another 3 combinations, which totals 6 right now. I'm done with blue. I go on to red, red, and a triangle, red, and a square, red, and a circle. Again, I'm done with red, and I have 3 more combinations, which means right now I'm up to 9 total possible combinations. I'm still not done with green, so I can do green and a triangle, green and a square, green and a circle. And that adds another 3 combinations, which totals 12. I have matched up all my possible combinations, so what I end up with at the end is there are 12 possible combinations. Let's look at a different one. This one here at the bottom, we're packing for a trip. The clothes to pack are blue jeans and khaki pants, red t-shirt, blue t-shirt, white t-shirt, black t-shirt. We need to figure out how many possible outfits can be combined and see how many total outfits we can make with what we are packing. So again, I'm going to just write down what I have. I have blue jeans and I have khaki pants. Now the first way we organized was just a list. This time I'm going to do a tree. A tree just uses branch-like tools so that we can organize under our main topics. I have blue jeans or khaki pants. Well, I know with our t-shirts I could pair blue jeans with a red t-shirt. I could pair blue jeans with a blue t-shirt. I could pair blue jeans with a white t-shirt, and I could pair blue jeans with a black t-shirt. Again, I have possible combinations. For my blue jeans, I have 4. With the khaki, what do you think is going to happen? Red, blue, white, and black. Another 4 possible combinations, which totals 8. In both this example and the last, we saw a pattern start to emerge. Well, if we start to see a pattern start to emerge, back with our tiles and shapes, I could have solved this a little bit faster by looking at, okay, if I have 3 combinations for yellow, and I'm going to have 3 combinations for blue, I should have 3 for red, 3 for green, and that could be a multiplication problem to help me get my answer. Same thing with the blue jeans and khaki pants. If I know I can make 4 outfits with the blue jeans, and I would make the same with the khaki pants, I could do it a little bit faster by multiplying 4 times 2. Is that always going to be true? No. If we look at one like this, the instructions say choose 2 different letters from the word garden. Okay, so let's write out the word garden. If I can choose 2 letters, I'm going to start from the left and go to the right and organize. I know I can combine GA. I know I can combine GR, GD, GE, and GN. The problem with this one is when I start on the A, if I go backwards, was GA the same as AG? Yes, they're just in a different order. And because our question did not say anything about making sure they're in order, then GA and AG would be the same. So now I'm going to start off with A, and instead of going back to G, I'm going to go forward, AR. Then I could combine AD, AE, and AN, and I'm done with A. Then I go to R. Again, I don't want to go backwards because I already have RG. I don't want to go back because I already have RA. I can go forward with RD, RE, and RN. There's another pattern emerging here. It's not the same type of pattern, but as you can see, we're missing 1 every time. We're getting smaller. Now that I'm done with R, I move on to D. Again, I can't go backwards, so I go forwards. DE and DN. Now I'm on E. I can't go back anyways, so I have to go forward. EN. My last letter is N, but if I go backwards, I already have NG, I already have NA, I already have NR, ND, and NE. So all of those would be duplicates. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 combinations total for that one. So the pattern's a little bit different. We can't just take 2 numbers and multiply them. So make sure that you see a pattern emerging before you just go ahead and multiply. The last one we're going to look at is one that is a little bit more involved because there are more than just 2 things happening. With this menu, we have soup, sandwich, and drinks. Well, the rules for our question say that we need to have a soup, a sandwich, and a drink. So if you start again, just organize split pea soup. Okay, so I'll put split pea soup. Well, with split pea soup, I could either have a tuna sandwich with milk, that's one combination, or I could have split pea soup with tuna sandwich and juice, that's a second combination. But I'm not done with split pea soup yet because I had another option with a cheese sandwich. So split pea soup, cheese sandwich with milk would be a third option. Split pea soup with cheese and juice would be a fourth option. But now I have another sandwich that I possibly could do. So now I have split pea soup and a ham sandwich with milk. That makes a fifth combination. Split pea soup with ham and juice makes a sixth combination. Now there is a pattern emerging, because if I have 6 combinations with split pea soup, what's going to happen with chicken noodle soup? Chicken noodle soup should also have 6. So now at this point I could just say 6 times 2 equals 12 combinations.